In earlier assessments, the global ranking of land-based anti-ship missiles placed China's DF-21C and DF-21 at the top, followed by the American PrSM Increment 2, and then Russia's Kinzhal, Iskander MAM, and Bastion P. These rankings were built mainly on range, speed, and warhead mass, metrics where Chinese missiles excel with their 1,500 to 4,000 kilometer reach and hypersonic velocities. However, this traditional framework overlooked two critical warfighting factors: mission flexibility and the cost-exchange ratio in a drawn-out campaign. When those variables are introduced, the balance of advantage shifts dramatically, and the PrSM Increment 2 begins to challenge the long-range specialists in operational relevance. The following analysis re-evaluates the hierarchy by examining the deeper design philosophies behind each missile family. The DF-21 family is not a single weapon, but a collection of specialized modifications, each tailored to a distinct mission set. The DF-21C, designated CSS-5 Mod 4, is a land attack variant carrying a 2,000 kilogram conventional warhead and reaching roughly 1,694 kilometers, and was fielded in 2006 to strike fixed high-value ground targets. The DF-21D, or CSS-5 Mod 5, is the dedicated anti-ship ballistic missile introduced in 2010, armed with a 600-kilogram penetrator optimized for piercing the deck of an aircraft carrier and a range of about 1,546 kilometers. Both missiles share the same basic rocket stack, but their guidance packages and warheads are fundamentally different, requiring separate production lines and logistics chains. This specialization means a commander cannot simply task a DF-21D battery to destroy a mobile surface-to-air missile battery without accepting a major mismatch between the weapon's design and the target. The DF-21 intermediate-range ballistic missile stretches specialization to intercontinental distances. In its DF-21C land attack configuration, it can deliver an 1,800-kilogram unitary or submunition warhead against fixed installations up to 4,000 kilometers away, giving the People's Liberation Army Rocket Force the ability to hold Guam and other distant bases at risk. The DF-21B, or CSS-18 Mod 1, is the anti-ship variant, carrying a 1,200-kilogram conventional warhead and presumably an active terminal seeker to engage moving carrier strike groups at the same 4,000-kilometer range. Both variants were fielded around 2016, representing a quantum leap in China's anti-access capability. Yet again, the two missions are divided between different modification standards, forcing the rocket force to guess which threat will materialize when they load a transporter erector launcher. Specialization offers undeniable engineering advantages. Warheads, seekers, and trajectories can be optimized until they perform one task exceedingly well. A DF-21D penetrator is designed to survive the shock of hitting a steel flight deck at hypersonic speed, while a DF-21C high explosive blast warhead spreads damage across a wide area. However, specialization also introduces strategic rigidity because weapons tailored for a single role cannot be rapidly repurposed when the battlefield picture changes. If a carrier group suddenly retreats and a battery of DF-21D launchers is left without a valid maritime target, those rounds cannot simply be redirected against an advancing armored column or an air defense network. This inherent inflexibility is the hidden cost of China's otherwise formidable missile arsenal. The Precision Strike Missile Increment 2, also called the land-based anti-ship missile, was designed from the outset to break the specialization paradigm. Its defining feature is a multi-mode seeker that combines radar and infrared imaging, enabling the same round to lock onto a moving frigate in heavy seas or a relocating S-400 battery on land. This seeker operates autonomously in the terminal phase, reducing dependence on external targeting networks that are vulnerable to jamming and kinetic attack. By integrating both land attack and anti-ship capabilities into a single airframe, the PrSM Increment 2 gives field commanders an unmatched degree of operational flexibility. The missile does not need to know what its target will be when it leaves the pod. It finds and classifies the threat on its own during the final seconds of flight. A frequent objection is that the PrSM Increment 2 carries only a 91-kilogram warhead, far smaller than the 600-kilogram penetrator of a DF-21D or the 1,200-kilogram punch of a DF-26B. While this limits its single-shot destructive power against supercarriers, modern naval combat is rarely decided by a single hit. A salvo of a dozen PrSM rounds arriving almost simultaneously can mission-kill a capital ship by destroying radars, flight decks, and communications arrays, even if the hull remains afloat. Against mobile air defense targets like an S-400 battery, the smaller warhead is actually an advantage because it lowers collateral damage while still obliterating radar masts and launcher vehicles. Precision, salvo density, and terminal autonomy compensate for the lack of raw explosive mass. Where the PrSM Increment 2 truly rewrites the rules is in its unit economics. At an estimated flyaway cost of $1.7 to $2.8 million, a single PrSM costs roughly as much as a high-end guided artillery shell, placing it in a completely different category from Chinese anti-ship ballistic missiles. Even conservative estimates price a DF-21D at $10 to $15 million and a DF-26B at $15 to $20 million, meaning that for the price of one DF-26B, the United States Army can deploy 8 to 12 PrSM Increment 2 rounds. When scaled up to the fiscal year 2027 planned procurement of 1,134 missiles, the arithmetic becomes overwhelming. The U.S. can afford to fire massive salvos at high-value targets and still maintain a deep magazine for follow-on strikes. This cost-exchange ratio transforms the missile from a scarce, carefully husbanded asset into an expendable munition that can be used liberally in the early phases of a conflict. Production volume is a strategic weapon in its own right. The Lockheed Martin production line is scaling toward a rate of 550 missiles per year, supported by a 7-year framework agreement with the Department of Defense. By contrast, the DF-26 force is assessed at dozens of launchers, not thousands, because each round is large, complex, and expensive. In a prolonged Pacific campaign, the side that can sustain high-volume precision fires will have a decisive advantage, regardless of the maximum range of any single system. PrSM Increment 2 is designed for exactly that kind of industrial endurance, where a week of operations can consume hundreds of rounds without exhausting the national stockpile. There is a persistent argument that DF-21D and DF-26B can themselves be used against land targets, blurring the line between specialists and generalists. Technically, any ballistic missile with a maneuvering re-entry vehicle can be aimed at a fixed coordinate and function as a land attack weapon. However, both the DF-21D and DF-26B carry anti-ship optimized warheads that are lighter than their land attack siblings and designed for deep penetration against hardened naval steel, not for area blast effects against ground installations. Employing an anti-ship penetrator against a dispersed air defense site yields poor cost-effectiveness, especially when a dedicated land attack version already exists in the same family. The presence of separate DF-21C and DF-26C variants confirms that China itself views these missions as distinct enough to warrant different hardware, underscoring the limitation of the ASBM variants in the land attack role. A critical footnote to any discussion of the PrSM Increment 2 is the status of the AGM-88G Advanced Anti-Radiation Guided Missile Extended Range. In fiscal year 2027, this program received only $20,000 in new procurement funding, effectively placing it on strategic pause while technical failures are resolved. Its absence creates a dangerous gap in the suppression of enemy air defenses because without modern anti-radiation missiles, the radars that protect Chinese carrier groups and coastal SAM batteries remain fully operational. PrSM Increment 2 missiles will have to fly through the engagement envelopes of these unsuppressed systems, reducing their probability of survival regardless of how sophisticated their seekers are. The synergy between seed weapons and land-based anti-ship missiles is essential, and the pause puts extra pressure on the PrSM to overcome defenses it was never designed to face alone. Chinese anti-ship ballistic missiles are renowned for their range and speed, but their effectiveness is entirely contingent on a fragile and highly complex targeting kill chain. They depend on a network of ocean surveillance satellites, over-the-horizon radars, and high-altitude drones to find and track moving carriers, then feed continuous updates to the missile in flight. If any link in that chain is broken by jamming, cyber attack, or anti-satellite operations, the missile reverts to blind inertial guidance with a drastically reduced probability of hitting a maneuvering ship. PrSM Increment 2, by contrast, carries its own terminal seeker that actively searches for the target independent of external updates during the final phase. This autonomy makes it far more resilient in a degraded C4ISR environment, an edge that is frequently undervalued in peacetime range-on-range comparisons. Russia's offerings in this domain remain regionally formidable but strategically limited. The Iskander M is a quasi-ballistic missile with a range of 400 to 500 kilometers and a speed of Mach 6 to 7, capable of limited retargeting against moving objects when paired with airborne sensors. The He-47M2 Kinzhal is an air-launched hypersonic weapon reaching Mach 10 over ranges up to 2,000 kilometers, but its dependency on MiG-31 or Tu-22M3 platforms makes it an aviation asset, not a ground-based missile system. The Bastion P coastal defense system fires the P-800 Onyx, a supersonic cruise missile with a 300-kilometer range and sea-skimming profile, useful for denying littoral waters but irrelevant for deep maritime strike. None of these systems combine a multi-mode seeker, strategic range, and mass production scalability in the way that the PrSM Increment 2 does. When the criteria for ranking expand beyond range and warhead mass to include mission flexibility, cost, and production volume, the hierarchy of land-based anti-ship missiles transforms. The DF-26 family retains the crown in terms of raw reach and destructive power, a position no other ground-launched weapon currently challenges. However, the PrSM Increment 2 overtakes the DF-21D as the second most operationally consequential system because it can engage both ships and mobile land targets, is cheap enough to be fired in saturation salvos, and can be produced at a tempo that sustains a long campaign. This is not merely an incremental improvement, It is a fundamental redefinition of what a land-based anti-ship missile can do on a modern battlefield. If a conflict erupted in the Western Pacific today, Chinese carrier strike groups would likely operate behind a layered defense screen at distances exceeding 1,500 kilometers from American launchers. The DF-26B would be employed to threaten U.S. surface action groups from extreme range, while DF-21D batteries would cover the inner seas. PrSM Increment 2 units deployed on HIMARS and M270A2 across the first island chain would be tasked with striking any Chinese naval asset that ventured within 500 kilometers of the shore, as well as hunting mobile air defense systems that threaten Allied air operations. In this scenario, the PrSM would not need to outrange the DF-26. It would only need to make any close-in Chinese operation prohibitively expensive through high-volume, multi-axis salvos. The deepest strategic advantage of the PrSM Increment 2 is not in any single parameter, but in its unification concept. The United States can manufacture one missile that serves as an anti-ship weapon, a land attack munition against high-value mobile targets, and in the future, with Increment 3, a delivery system for submunitions or loitering payloads. China must maintain separate production lines and inventory buckets for DF-21C, DF-21D, DF-26C, and DF-26B, each competing for budget and industrial capacity. This unification multiplies logistical simplicity, accelerates training, and allows battlefield commanders to adapt to fluid tactical situations without waiting for a specific weapon variant to arrive at the front. The DF-26 remains the undisputed heavy hitter of the land-based anti-ship world, a weapon that can reach across the Pacific to threaten high-value bases and fleets from the safety of interior launch positions. Yet, the PrSM Increment 2 has carved out a new category of its own, one in which affordability, flexibility, and volume are decisive as raw range. In the evolving Indo-Pacific security environment, the ability to fire thousands of cheap, smart missiles from distributed mobile launchers may prove more disruptive than a smaller number of ultra-long-range rounds. The balance has shifted, not through a single technological leap, but through a quiet revolution in how we define battlefield value.